Okay, so either circle, highlight, or something up here where when we talk about a polynomial, it's the sum, which could be minus, okay, because we're going to make it in a plus. It's the sum of monomials that form an algebraic expression. So, a term can be a number, a letter, which is, excuse me, your variable, or the product, or of several.
Is that off the left?
No, look at your paper. So if we have this right here, we've got these terms, 2x squared, 3x, and negative 5. The reason they're terms is because they're being added together. Look at the first part of each of those. Monomial means 1. We have one term. It has 2 terms. It's a binomial because this means 2. It has 3 terms. It's a trinomial, 3. So when we're talking about vocabulary, that's what a vocabulary is talking about. If it just says polynomial, it can be all of those, but specifically, it can be the monomial, trinomial, or binomial. So if you want to identify what type that they are, those 3, monomial, binomial, or trinomial, or polynomial, which means many, poly means many. What's number 1? What's what these things? Binomial. Because we have 2.
Better than one thing up?
Yes. So you have 2. So what about number 2? How many terms we have? 3. So we have trinomial. And number 3, how many terms we have? 1, because there's no addition or subtraction here. So we only have 1 term. Mono means 1. Monomial. And here, how many terms do we have? 4. So, 4 or more is a polynomial because it should be a yield. Because that stands for this, stands for many. So, we've dealt with expressions, we've talked about like terms, all that kind of thing. We're just going to go a little bit deeper into some vocabulary because that's what you're going to see. Okay, since they can be added together, they have like terms. That part we've already talked about. Do this pretty much the whole first semester. Combining like terms. We didn't necessarily have exponents. Okay, now we've got exponents besides a 1. So, we've got to be careful about our exponents. So number 6. 6xy, 8xy. Are those like terms?
Yes.
Yes. Because you're looking at this part right here. Not the coefficient. Okay, the number that's in front, that's a coefficient. The number part is constant. It's constant if you have any letters with it. That's a coefficient. If the letters are the same and have the same exponent, it is like terms. What about number 6? No, because what's the exponent on this x? 2. That was a 1. 2x to the first, 3x squared. So, no, you don't have the same exponents. You couldn't add those together. What about number 7?
Yes.
Yes. I don't care what the coefficient part is, the number part. We're looking at the letters and exponents. What about 8?
No.
Yes.
Okay? Yes, because if there was a letter, it would be something to the 0 power. But I want you to add something under here. I want you to write the word constant. Numbers without a letter is a constant. So if you see that term, that's what it means. We don't always use the appropriate terms when we're going over things, but that's what that means. Okay, so to add polynomials, we're going to collect like terms. This is something that we need to make sure that you highlight or circle here. Only the coefficient will change. The variable and the exponent do not change. Okay, we went through the whole thing about exponent laws. If you're multiplying, keep the base, add the exponent. If you're dividing, keep the base, subtract the exponent, multiply the exponent. We're not doing that. Okay, we are adding polynomials together, which means you have 3 of them here, you have 5 of them here, so you have 8 of them. Whatever the deal is, whatever the term is, you keep it. So number 9, we're just going to add like terms. These are all addition. We don't have to worry about changing any signs. We're going to look at that in a minute. What's 2 plus negative 4? Negative 2. That's our x term. What's 3 plus 5?
8.
8. You're done. Just like we did before with expressions. There's no equal sign. Okay, you're done. Okay, number 10. Some people find it helpful to use a highlighter. If you want to say, okay, here's my, we did this before also, here's my x squared, here's my x's, here's my constants. So let's combine them together. 1 plus 1. Sorry. 1 plus 1 is 2x squared. Negative 8 and 6.
Negative 2, right?
Negative 2x. 7 minus 12, or 7 plus negative 12. Negative 5. Okay, so same thing down here on 11. Be careful of what you've got. I don't have any other x's to go with that. We can't make it up. If it's not there, it's not there. So, if we look at our x squared, 5 plus 6 is 11. And you have to write the term variable with it. It's not just 11. It's 11 of those things. Okay, whatever the x squareds are, y's, z's, doesn't matter. We don't have anything to put with that, but we have to write it. And then we have 3 and a negative 2. Which is the 1. Anything on 12. Here's 8x. There's 9x. There's a negative 7. There's a 4. This one doesn't have anything to go with it. We don't make problems where we don't have one. When it says combine like terms, that's all you need to do is combine like terms. So we want to go with descending order, if at all possible. So x squared is my highest exponent. There's nothing to put with it. It's 1x squared. Right. We have 8 plus a negative 9. Negative 1. This has to go with it. Negative 7. Negative 7 plus 4. Negative 3. And so whatever the sign is that's in front of your number, your coefficient, is what you have to use. Seem familiar to everybody? Should? Okay, we've done this quite a bit. Okay, look on the back. You know it has to be a little more difficult. Here's the top that says when polynomials become more complex, it may be easier to add them in columns. This is an option. Over on the other page, you can draw arrows, you can use a highlighter, or whatever. You can do the same thing here. Or, something that may be a little bit easier is to do it in columns. Well, if we look at 9x to the 5th minus 2x to the 3rd plus 6x squared plus 3rd. We don't have an x to the 4th term here. We don't have an x, single x term here. But we can line these up where maybe we can see straightening out a little bit easier. So what I'm going to do, and this might be helpful for some of you that get them mixed up, is I'm going to rewrite this. 9x to the 5th, and then I don't have an x to the 4th term, so I'm just going to make it 0. Minus 2x to the 3rd, plus 6x squared, plus 0x, plus 3. I guess this will be really helpful when you get to maybe some that are really mixed up. So now I have 5, 4, 3, 2. If I needed to write it 1, okay, I've got every term. There's no one there, multiply to the 0. Okay, the other one says plus. Well, I'm going to write these underneath where they match up. 5x to the 4th. I don't have an x to the 3rd thing, so I'm just going to put a 0. I have a minus 7x squared. I don't have a 0 an x term, so I'm going to put 0 plus 6. And then I'm just going to add. They're both valid ways. It makes no difference. It's the same answer. Pay attention to what you're doing. So, I don't need anything to add to 9x to the 5th. Okay, if I'm just looking up here, I'm like, okay, use that up. I'm okay, I need a 4th. Well, add those together, I have 5x to the 4th. So I use that one up. 3rd, I've got 1/3. Gotta keep your sign with it, so I use that one up. This is the first one we can actually combine on the squares. 6x squared, negative 7x squared. So if I look at it right here, we've got negative 1. Okay, I use those up. I don't have any x's. I can write 0x, but I don't need to. Those are just not there. And 6 plus 3 gives me 9. You need to go slow, take your time, and do it correctly. Okay, rushing through it to get it done faster, wrong, is not going to be helpful. Okay, take your time and do a little bit more slowly. This one, maybe you don't want to do all that. You just want to combine like terms. It's okay? You're going to look through first and it's okay. My highest one is to the 3rd. So, these two can go together. So if we put those together, what are we going to have? How many x to the 3rds? 2. We got 2x to the 3rd. And say, okay, I'm going to look through it. I've got 1x squared term. There's nothing to put with it, so all I've got is that one. And I would suggest that you use your pencil and like, okay, I already used that one up. So you're confused on it. Okay, well now I need my x terms. Well, I've got one here, and I've got one here. They're both negative. So negative 17x. Okay, so I use those up. Then we have a positive 3, positive 7, and negative 9. What's 3 plus 7 minus 1? 1. Okay. It is easier to add the opposite. So, when you work these problems, if I don't see it on your paper and you miss it, I'm going to put a big old X on it and you have to go do it over again correctly. Because this says to subtract polynomials, you'll find it easier to add the opposites of the polynomial being subtracted. Right over here on the top, I want you to write change all, underline it, signs in the second polynomial. Here's not a problem. You do the same thing you've been doing before. If we have a subtraction problem, like that, we're going to change it where we have only addition. So what I want you to do on every single one, that you have subtraction, look at your problem first. We're not changing the first one. This stays exactly the way it is. But here, we're going to make this addition. But we have to change the sign of everything that comes after it. So if I write a little bit bigger where we can see this, we're going to say 9x squared minus 3x plus 7 plus, and this is the one we changed, this one right here, instead of a positive 2, we have a negative 2x to the third, squared, okay, x is squared. Instead of a positive 4, we have a negative 4. Instead of a positive 6, we have a negative 6. Because if you don't change it, what happens 9 times out of 10? Is you say 9 minus 2 is 7x squared. And you're right. And then you say negative 3 plus 4 is 1. No, it's not. That would be negative 3 minus 4, which is what you have seen right there. And this is not 7 plus 6. This is 7 plus negative 6, or 7 minus 6. That minus applies to everything that comes after it. And that's where we end up having an issue. So you just need to have, just like we have in the very beginning of the year, if it's minus or negative, there's a little red flag to you that you can pay more attention. Okay, I'm going to erase that so I'll have a little bit more room to write this. Okay, so this last one here, I have 17x to the 5th plus x to the 3rd, that should be, minus 9x, and then minus one that's not the same thing, minus 3x to the 5th, minus 4x to the 3rd plus 5. So, first thing, second polynomial, add the opposite. That's positive, makes that one negative, makes that one positive, makes that one negative. You can just do what you were doing. So look at our x to the 5th. We have 7 and negative 3, which is what?
4.
4. We have our x to the 3rds. We have 1 and 4, which is what? 1 plus 4? 5. We have a 9x that can't be combined with anything. And then we have minus 5. Because that was minus a positive 5, which is the same as plus a negative 5. So those signs have to be correct.